Hello, welcome to Decision Trees and Random Forest in Python. I assume you have done some sort of review on the statistics and theoretical part of random forest and decision trees. I have imported some libraries here, NumPy, Pandas, Matplotlib, and Seaborn, no surprise. And I have read the CSV file called kyphosis. So let's take a look at the data frame here. Okay, so I'll do a brief explanation on each of the columns here. So we only get 4 columns for this data frame. The first one, kyphosis. Kyphosis is a kind of spiral condition. The way to solve that is by doing the corrective surgery. So the first column is after the patient accepted the surgery. Okay, is the kyphosis absent or is that still present? In the second column, age, is the age of the person in months. So basically this data set is for children. In the third column, number, that is the number of vertebrae that are involved during the surgery. And the fourth column, start, that is the position of the vertebrae the surgery started at. So for example, 5. So the surgery started at the 5th vertebrae. So here is the basic explanation of the data frame. So I always suggest to do some EDA, exploratory data analysis, before we start training and testing our data. So since the data frame or the data set is pretty small, I suggest you just use the pitplot. So seaborn.pitplot and the data frame. We'll set the hue to kyphosis. Okay, so here we can see some histograms and also some distribution plots among these features. Okay, and then the next step is the training data and testing data. We're gonna do a split up. Okay, so from, if you do remember what we have done for logistic regression, for KNN, for linear regression, so from klearn dot models selection, import train test split. Okay, and what should be my x and y? X are the feature columns, right? So look at this data frame here. What is my target class? The kyphosis. I want to see if the kyphosis is absent or not, right? So this is my target class. So the rest of the columns here are my feature columns. So age, number, and start. So what I can do is I just I'll say the whole data frame except the kyphosis. And don't forget about setting the access to 1 because that is for column. And then y will be kyphosis. Okay, so the next thing is shift tab, read the documentation, save some time. Okay, so I will set my test size to 0.3 as usual. Random state to 101, my favorite number. Okay, so next thing, we'll start by training a single decision tree. So from sklearn.tree, we input something called decision tree classifier. Okay, and then I will declare a variable called dtree to instantiate the decision tree classifier. And then what we're gonna do is I will use that to, I will fit the model to my training data, X train and Y train. Okay, and now time for us to do some predictions and to do some evaluation. Okay, so I'll just call it pred equal to d3 dot predict x test and pass the testing data set to as the parameter, and from sklearn dot matrix, right, and we import, we're gonna import two things. So first one, classification report, and also confusion matrix. Okay, and then we print the result. So classification report that is based on, so the practice will be the parameters that are passing will be my test and my prediction. Okay, and then the second one is my confusion matrix, also based on y test and pred. Okay, so you can see here the precision recall and the accuracy is around 60%. I'll say that is not good. Okay, so the result doesn't seem good, but that's okay. We're gonna start with compare this single decision tree with my random forest classifier. So what we're gonna do is from sklearn dot ensemble import random forest classifier. So why this one? Why the random forest classifier is not from sklearn.tree, but it's from ensemble sklearn.ensemble, because this is kind of like a bunch of decision trees, right? The whole bunch of decision trees. So that is why it is from the ensemble package. Okay, and then I'm gonna instantiate this random forest classifier. I call it RFC. Random forest classifier, and if you read the documentation, you'll know that we can pass in the number of estimators. I'll set that to 200. Okay, you can do some adjustment on the number of estimators, but our data frame for today's, because the data set is quite small, so I say 200 can overkill that, but that's okay. I'll keep it as 200. And then RFC the fit, I'll fit that to my X train and Y train. Okay, and now I use that to predict. So the pred, I just cut RFC pred will be RFC the predict X test, and then let's print the classification report and also the confusion matrix here. Okay. So this one should be RFC underscore pred, RFC underscore pred. Okay, let's fix this. Okay, by comparing the results, the precision, recall, and accuracy, you can find that um, the random forest is way better than the model of a single decision tree. Okay, and also if you compare the confusion matrix, the 0 and 4 here, yeah, seems like the random forest is better because the data set is quite small for today's comparison. But usually, like if you use a huge data set, the random forest is always the winner. Okay. But one thing that I have to mention here is uh, if you take a look, of the data frame here, if you do value counts of absent and present, what you're gonna see is the cases of absent is around 80 or 70 to 80%, and the case of present is just 20 to 30%. But as I mentioned in machine learning, if you want uh, to train a model to do some predictions, we have to keep our data balanced, right? Do you remember the cat and dog example? You cannot just put one cat picture versus 99 pictures of dogs. Okay, it's not fair, right? So in this case, I would say unbalanced data set might affect the result of your model prediction and evaluation. Okay, so I always suggest you to have balanced data set. Okay, so that is all for decision trees and random forest, and I'll upload the homework later on. Thank you.